Hi Year 10s, welcome to our first video of graphs and algebra, and in this one we're going to be talking about x and y axis graphs. And so very quickly, when we've got a graph, we've got an axis going up and down and an axis going sideways. The one going sideways is always x, and the one going up and down is always y. And that's just a convention and something that you'll get used to very quickly. So in this example here, it's asked us to use this table to draw a graph showing the stopping distances for the cars at certain speeds. So what I'm going to do is put in a set of axes to show that. And so there's my two axes. I'll just check that they're big enough. Okay, and just before we read it, we'll just read just before we do it, we'll just read this first question, which is asking us which label should go on the horizontal axis, speed or stopping distance. And we're going to put speed on the axis, and the reason why we do that is that's called our independent variable, and your stopping distance is dependent on your speed, and so that means that we put speed on our x-axis and we put stopping distance on our other axis. So now we can put in our scale, and so I'm going to have my first one for speed at 25, and we'll go up and set to 25 for our speed. And you can see I've just made our stopping distance a little bit bigger so that we can have the same scale for our stopping distance. And you'll just notice that the stopping distance is measured in meters, and the speed is measured in kilometers per hour. Okay, so now it's time to plot these points, and so our first point occurs at 25.6, so that means that we have a point at 25, and 6 is going to be very low. We'll have to estimate it, but it'll be about there. Okay, then we've got 50 and 24, 75 and 54, so it'll be about there. 196 and 125 and 150. Okay, so you can see here it's not just a straight line, it actually gets a lot bigger as you go faster. Okay, so it says explain how you could use this graph to work out the stopping distance for a car travelling at 90. So what we could do there is sketch in a sort of a trend line, if you like, and then we could come up at 90 kilometers an hour, which will probably be around about here, and wait until it hits the line and then come across from that. So it looks like if you're travelling at 90 kilometers an hour, it'll take you approximately 80 meters to stop. So we'll write 80 meters stopping distance for that one. In question 4, what are some advantages of using graphs like this? Well, really, this lets us predict stopping distance for other speeds that aren't necessarily on the graph, and can also illustrate the fact that the faster you go, the proportionally more distance you have to stop. Okay, I've got another example I want to go through, and I'll do that in my next video.